So we're finishing up 2.14, and there might be one new thing from from Friday today, but that's it. Sorry. I got my throat. All right, I'm going to start recording too. I get it a lot. We have a quiz on Friday. Not open note, in class. Old-fashioned paper pencil, like regular test or quiz. All right, I think I'm done. So today finishing up 2.14. Tomorrow is 2.15 one day, and then 2 days of quiz review, Wednesday, Thursday. We don't really need 2 days, but I just decided to give us 2 days because we have the time. So you can use those days just to make sure we feel really good about this quiz. 10 questions. My review is just like the quiz, kind of like I do my test, okay? Bad news is tomorrow's 2.15 notes, I don't like the notes I already gave you. I'm going to try and do better, guys. In Unit 3, in our last unit, I'm going to try to, before I print, put in the new notes, okay? So I know I've done a really bad job of that this year. Forgive me. But so tomorrow I will be handing you guys a packet as you come in. That'll be tomorrow's notes and homework. And I went ahead and included the quiz review with that. So you'll have the rest of the week's work in that little packet, okay? And so, like I said, today we're doing very much like what we did on Friday. I think everyone was here, maybe except one of you. So this is going to be great practice of what we were doing. And remember, I told you that what we're doing right now, again, is very, very much like FRQ2 on the AP exam. And I'm going to prove it to you here in a second. But let me read this word problem. A textbook publisher added a new AP Pre-Calc curriculum product to their sales catalog. The first day, they're calling time day, first day is T equals 0, sold the curriculum to 14 school districts. 21 days after the product was added, so they called that day 21, they sold 62 of those products, okay? The number of textbooks sold on a given day can be modeled by this function. So they're always going to give you a model for you to plug your numbers into, where B of T is the number of products and T is your time in days, okay? So B of T is Y, T is X. And those things I underlined at the beginning are really just ordered pairs. We have X and Y and X and Y. And this FRQ is calculator active, meaning you will have access to your calculator for this FRQ. And I told you about it on Friday, but I want to show it to you, okay? This is the actual FRQ2 that my last year students had. And if you just do a skim through this word problem, you can see it's very similar. It just has to do with video games instead of curriculum products or whatever. But there's 2 ordered pairs in there. You can see the model of the equation. And look at part 1. Use the given data to write 2 equations. Use the given data to write 2 equations. Part B, find the values for A and B. Same thing here. Part 2, find the values for A and B. And we're going to do those 2, which we learned on Friday. We're going to do one more. We're just going to do part C. And that is to find the AROC, which is a slope. And you can see right here, use the given data to find the AROC. Okay, so I'm showing you, we are starting our training right now. Well, really everything we do in here is like learning what we need for the AP exam, but here's like a really good example. So I'm going to go through this. Now, what I told you on Friday, I fibbed a little bit. I should know at my age and my number of years of teaching, I should never say always or never. Those are 2 bad words to ever use, right? And what I told you is you can use your graphing calculator on this. So you don't really have to show any work for parts A and B. We'll get to part C in a minute. But let me just show you without you having to take the time to do it. If I wanted to do this in my calculator, I'm going to run into a problem. So we will review the calculator steps in the next example, so don't worry about it right now. But you would go to Stat, Enter, and my X values are my list 1, and my Y values would be 14 and 62. And then remember, we go to Stat, Calc. I'll go through all this again in a minute. 9, enter, 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 enter. And what happens with this is you get an error. And that's because what we're trying to plug into the calculator is an x value of 0. Well, you guys know that this can never be 0. You can never have a 0 there. So because there's an asymptote, so the calculator is not letting us do it. So there is a little bit of work we have to do. And by the way, they had a 0 in this one too, the one that my students had last year. So it's really a very similar problem, almost exactly like the one that they had last year. So let's first do part A, which is just to create the two equations. So you have to do this by hand anyway, just plugging in x and y into this equation. So we would have 14 equals a plus b natural log of 0 plus 1, and 62 equals a plus b natural log 21 plus 1. And so that's part A. That's it. That's all you do. Yeah, sorry. Good. All right. Now we have to find the values for A and B. And it doesn't say, you don't have to show any work, but there is a little bit of work we have to do. So for example, if I go to that first one that contains a 0 and I simplify that, 0 plus 1 is 1, but natural log 1, you might remember, or you can put it in your calculator, natural log 1 is 0. Can't see it, but it's 0, okay? So anytime you have a log, any base, it doesn't matter. With a 1 here, it equals 0. Well, if natural log 1, that whole thing equals 0, and then b times 0 is also 0, you're just left with a equals 14. So pretty simple work right there. And then now I can take a is 14 and plug it in right there. So 62 equals 14 plus b natural log of 22. And it's added 21. And I'm going to solve this equation. And you're allowed to use your calculator. You don't have to show all the steps. As a grader, I wouldn't even be looking for your work. It wouldn't matter what your work is. All I care about is your A and your B. So you could show as much or as little work here as you want. So I subtracted 14. And then remember your goal is to get b. We're trying to get b by itself. So right now this is b times, right, times natural log 22. So we can divide both sides by natural log of 22 and get b equals 48 divided by natural log 22. And that would be, let's write it over here, 15.529. Okay? And that's it for part B. So not too bad of work, okay? Now, optional, and you'll see this in my keys. So by the way, number 6, 7, and 8 of your homework is 6, 7, and 8. So you're going to do exactly a problem just like this in the homework, same exact steps. What we found last summer when we graded this is a lot of students didn't write A equals B equals. They went ahead and plugged the A and the B back into the equation. That's fine too, because we know to look for the A and the B there. So it's optional to plug A and B back into the original function, or you can just answer the question exactly like it is, and it says A, just find A and B. So either one, and you might have noticed that in some of my keys, like on Friday, I feel like some of them, it's just ask for A and B, and I put it in the function. Either way, it doesn't matter. That is still giving us A and B. Yeah. All right, this is the new part, part C. Use the given data to find the AROC, okay, the average rate of change from 0 to 21. Give your answer as a decimal, and it does say to show the computation. So they will be looking, I will be looking for the steps here, okay? So let's remember, AROC is just slope, okay? If we were doing Algebra 1 linear equations and I gave you 2 points and said find the slopes, you'd go, oh, 62 minus 14 over 21 minus 0. We're going to write it a little more varsity math level, I guess is a way to say it. So remember, what we always do for slope or AROC is the change in y divided by the changes in x. Okay, that triangle always means change. So you do always have y's on top, x's on bottom. All right. Now I'm going to write something and then I'll explain it a little better. B of 21 minus B of 0 over 21 minus 0. Is that step necessary? Not necessarily, no. The next step is really what needs to be written. But I'm writing this because I'm finding that we're still, we as AP Pre-Calc students, are still getting confused with some of our notation. Remember, b of 21 is fancy talk for y when x is 21. So b of 21 means the y value when x is 21. So I can just replace b of 21 with 62, right? What is the y value when x is 21? It is 62. Minus, what is the y value when x is 0? 14. And then the rest of this is just calculator work. Show as much or as little as you want. 62 minus 14 is 48. This step you could totally skip. We've just done the rest of it in your calculator. Divided by 21 is approximately 2.286. And we're going to label this answer y's over x's. I'm going to say 2.286, our y values were products. You just go back up to the word problem to see what it is that we're talking about. And then, what did I say on the bottom, time, days. So we sell about 2.286 products per day. So it's just the y's over the x's. And again, you can go back up here and read what words to possibly use for those two letters. Okay? So A, B, and C is just like 6, 7, 8 in your homework, just like half of the FRQ2. There's a little bit more to it that we'll cover later in the semester when we review. All right? All right. Let's do 2 more examples, just practicing with our calculator steps. Remember, you have to know how to do all the calculator steps on a quiz, on a test, on the exam. So that's why we're practicing a lot. And we've been doing this a lot this year even. So the minute you see that they want us to make a log regression, when you hear the word regression, you think, oh yeah, that's my calculator model. That's when I do stat, that stat stuff that we do all the time. Regression means stat. So let's clear your RAM, go to stat, and do me a favor and go ahead and enter your L1s and your L2s, and then we will jump back in and answer the rest of the questions. Christian, you doing this with us? So understand, when they give us a table of values, that's our actual data. So you can think of this as like the actual, what happened. It's tied to some word problem, some real world problem, which they didn't give us, that's fine. But this is like data. Here's some real life stuff. What we're telling our calculator to do is take this info and we want it to be written as a log. Remember, there's a whole menu here. If we go to stat, calc, we can tell it to force this into a line, a quadratic, into anything. What do they want? Log. And we need to remember that that's number 9. Number 9 is your ln, which is natural log. Be careful because there's lin on there twice. That's linear. We want ln, which is natural log. So I'm going to hit 9, enter, 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 alpha trace, enter, 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 and we will get our A and our B that we'll plug in. And remember, if I put a hat on my Y, that's just labeling it as the model, as my regression formula. I'm not going to mark it wrong. Nobody would mark it wrong if you didn't put it there. So this is what your model is. We use it to find predictions. We're using it to get predicted answers, okay? So here we go with that. Use that Y hat, the log regression model, to predict the value of H. Now, where's H? I think Lady Jean, meant to make this Y and H of X. That's where she's getting that. But in a situation like that, we should understand that X is 4, so this has to be Y, right? When X is 4, and I need y, is that table or is it intersection? Table. Yeah, right. Go to your table, find x is 4, there's your answer. As long as you saved your function in the calculator, it should be right there in your table. So that'd be approximately 5.214. Okay? Right out of the table. We reviewed residual on Friday. This is a formula you need to know. R is your residual, which is y minus y hat. It's actual minus predicted. That's alphabetical order, if it helps you. Actual minus predicted. So here, actual data is what came out of the real world, out of our table of values. So it's right here, 3.7. So that's the x value you're talking about. The y value that goes with that data is 5.1. So there's my actual 5.1 y value minus, now I'm going to go to my table to find what is the y value when x is 3.7 in the table. Well, the problem is you don't have a 3.7. It goes from 3 to 4. But you can change that. So table set, which is above window, that means set the table, change the settings in the table. So we can go there, and there it says change in table. Right now it's changing by 1. 1, 2, 3, 4. We want to change by 0.1, so we can get a 0.7 there. And one more thing you could do right here to make your life easier is go back up to table start. That will give you whatever you want at the very top, so you don't have to scroll through to find it. I want to know what 3.7 is. So if I go back to the table, it's right there at the top. Careful rounding that one. That would be 4.99. And you can put the 0 at the end or not. Whenever your other digits are zeros, you can leave them off or put them for the same amount of credit. Subtract those right in my calculator, and I get about 0.11. Understand what a residual is. A residual is the discrepancy between what really happened and what the model is telling us being true, okay? And then the statistics people take those, a whole bunch of residuals, they would do it for every point, and they would make a graph out of these residuals, and they would analyze it. We don't do any of that really. We just find the residual, do the math for it, and we let the statistics people interpret it, okay? But we don't have to worry about that. I mean, we did a little bit. Remember, we did underestimating and overestimating, that kind of thing. We did touched on it, but we didn't really do a whole lot. Okay, use the model to predict when h of x is 9. This is y. So when y is 9, x is what? That is intersection, right? I mean, think about it, guys. You're typing in y equals 9. So this is where you have y equals, is in your graph. So y equals 9. We need to see the intersection. If you don't, change your window. X max, right? We want to go to the right, maybe to 30. There it is. And then we do second calc, number 5, enter, 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 and we have approximately 14.9, or 90, or 900. Any of those three answers would be fine. Okay? One more. Clear your RAM. If you want, while I read, if you want to start putting this data in, you can. Mr. Craig gave his students a poster of math properties. They studied the image for 90 seconds. Beginning one day later, a quiz was given each day to test the memory of the poster, their memory of the poster. The table represents the average score. So one day after they studied it, the score percentage, and you can see the scores went down. Here's my list 1. Here's my list 2. So go ahead and hit stat enter and get those in if you haven't already. you get your data in there. Stat, calc, 9, enter, 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 alpha trace, enter. Keep going until you get to the screen that's got your equation. And lastly, use your model, that's the y-hat, to predict the average test score after 14 days. Well, days is our x values, right? X is 14. What is y? That would be table, right? So just go to your table. Go down to 14, and you'll get 55.7%. So after 14 days, we can predict that the score. After 14 days, we can predict that the scores would be, this would be the average test score. Okay. And that's it. I already told you what 6, 7, and 8 are. Number 3 and 4 is 2-word problems where they give you an equation, you have to plug in and solve. So good practice solving some log equations. No, that's just one. That's C5. This is C6 today. Friday we omitted different. Page 171. And I'll scan it real quick and get it on Canvas. 1 second.